Hi and welcome to the final build episode on my Eclipson Model A. This is a 3D printed RC plane, on which I did some modifications to make the plane as fast as possible, as light as possible. And in this episode, in this final build episode, I'm gonna go through the electronics installation and the final steps I had to do on the plane. The finish you can see is just for the test flights. If the test flights are successful and I like the plane, there will be some work on the paint job. So let's have a closer look at the electronics installation. For this, let's take off the canopy. This is the final installation of all the electronics. The only thing you cannot see here is the aileron servos. They sit in the middle of each wing. The first steps I had to do was all the soldering and wiring. So I started with the KISS 30 amp ESC, which is a used ESC from one of my old 5-inch drones. Almost the whole electronics except the servos is electronics from a 5-inch quad. Also the motor, which is a Racer Star BR 2306 with 2400 kV, also took from an old 5-inch quad, and the same for step down regulator and the receiver. So I wired up the 30 amp KISS ESC, which runs up to 6S, then the step down regulator, which can handle up to 22 volts, and output is stepless adjustable. So I set it to exactly 6 volts, so I have good power on my servos, and it can deliver 3 amps, so this is more than enough for the servos and the other electronics I run in this plane. Because of the modified RC receiver, I had to cut off the connectors from the servo cables, because this receiver is just naked without any servo pins or case, and just to reduce the weight to a minimum and the size to a minimum. This is the reason why I had to solder all my servos onto the receiver. For an easy installation of the ESC, the step-down regulator and the receiver, I wrapped them in clear shrink tube, just to make it easier to put on some double-sided tape and fix the components in the positions you can see now. The servo horn shapes were a bit in bad shape, so I just cut them into a nice shape just to make the build look a bit cleaner. Then I had to figure out the servo position of the aileron servos. These are pretty small servos, and if I wanted to screw them onto the original servo mount on these plates, the servo horn will touch the plate for the servo horn. So I decided to remove the original mounts also here to reduce some weight, and simply glued the servos with some pour onto the plates and screw the plates into the wing. And like this, I still can remove the servos without any issues and get the absolute minimum weight of the installation. If I want to go further with saving weight, I perhaps will replace the screws with just some glue for the installation of the plate. I don't know if this is necessary. It looks pretty clean with the screws, but with the glue you can save some more weight. For the installation of the elevator servo, I chose another position than the stock position. The stock position is just underneath the wing, and because I glued the wing onto the fuselage, so there's no more possibility to remove the wing from the fuselage, I decided to go for another position. This also helps to get the right CG, because I use a pretty lightweight 4S 650 mAh battery. And in this case I need all the weight of the electronics as much as possible in the front, and with this position that works absolutely perfect to get a good CG. I took the original mount of the servo, screwed the servo onto the mount and glued the servo including the mount on the wall of the cockpit. Next step was to install the elevator linkage. I decided to go with a Delrin solution with the outer tube and the inner rod. I had to take the outer tube way out of the fuselage just to make the linkage stable enough. If I cut the outer tube in this position or somewhere around where it comes out of the fuselage, the rod is not strong enough. So if you have forces on the linkage, it will bend and you cannot control your plane anymore. So I had to take out the outer tube this way, and like this it works perfect. To fix the rod of the linkage on the servo side, I just used some clear foil with a hole in it and glued this foil onto the foam which holds the wing on the fuselage, which connects the wing and the fuselage. Like this, the linkage is well mounted and also super lightweight. The holes on the ailerons and the elevator are pretty big, and if you just put in a metal rod, you will have some play between the hole and the rod. So what I had to do, I took some cable isolation which exactly fits into the hole and pushed the rod through the cable isolation, and like this it's absolutely free of play. So my ailerons and the elevator have absolutely no play. The only play comes from the gear of the servo, but the linkage is absolutely free of play. The servo cables of the aileron servos were pretty short. They just ended up in the center of the wing, so we had to increase these cables with some additional cable around 15 centimeters, and like this the installation is pretty clean, and I have enough cable to take the RC receiver out of the plane if I have to solder or unsolder some servo connections. To isolate the solder points of the extensions of the aileron cables, I used some Plastidip just because it goes pretty easy and quick, and you don't have to fiddle around with some tiny little shrink tube pieces which sometimes already shrink if you solder your cables together. So the Plastidip solution is a pretty quick and simple one. Then it was time for a first electronics check if everything runs after the final wiring, and everything worked fine. All servos, the motor, ESC, everything worked perfect. Then it was time for the last big step on the build on the plane itself. That was to glue the wing onto the fuselage, and after all the electronics check I was ready to glue it on because I didn't have to access anymore the area underneath the wing. So I took some Hupor, put the right amount of glue Hupor all over the foam pieces and the fuselage, and put it on the wing and just checked if the position of the wing is correct. It's really flat, it's 90-degree angled to the fuselage, and just let it glue cure like this. Then I had to mount all the other components, the spinner, the prop, the canopy, just to check the CG, put it in a battery, 4S 650 mAh battery from China Hobby Line, and I just checked where I have to place the battery to get a perfect CG. I will start with a CG around 30% from the leading edge of the wing. That's around 5.1 centimeters from the leading edge. And I was pretty surprised that with this light battery and this light electronics I have built in, the CG is absolutely perfect at 30%. And I can also play around with the CG with moving the battery back and forth. Next step was an exciting one. I just did a short thrust test only to check if everything works, if the prop and spinner are mounted, and I was pretty surprised about the power of this little 5-inch drone motor, and I'm pretty excited how this thing will fly. As already mentioned, it's 2400 kV on 4S, on a 4.5 pitch prop, 6-inch prop, and the whole plane is in this configuration for test flights. It's 602 grams, and the thrust will be around 1.1 kilograms. So I think the performance of this plane will be pretty fantastic. For the battery mount, I took a carbon plate, which is a top plate from an old GPRC 5-inch quad. I just had to put a double layer of foamy double-sided tape underneath the plate just to make it possible to wrap around Velcro, and like this I can install the battery absolutely perfect and keep it in place during the flight. This is already it about the build of my 3D printed RC plane. Next video of this plane will be the maiden flight, so I'm pretty excited how this will end up. I'm looking really forward to the test flights. So thanks for watching, have a good time, happy flying, bye bye.